All right, guys, so it's 9:30. I think we'll get started here. Welcome to the session. This is Intent to Action, AI as the New CLI. So the whole concept of being able to configure, automate, manage, monitor your environments with natural language. My name's Craig. I'm a technical solutions architect on the enterprise networking team, and I'm based out of Vancouver, British Columbia, Canada. And this session is not at all about trying to sell you anything or push any kind of Cisco products. It's entirely about connecting your platforms to AI so that you can do some pretty cool things. Super quick mandatory WebEx slide. If you haven't already, you can download the WebEx app. You're able to join a Teams room for all the different sessions that you attend. It's a great place to ask questions during as well as after the session. I do have a couple of people that are going to monitor that room during this session, so feel free to throw questions in there. You should get pretty quick responses. And I'm also hoping to have some time at the end so that we can answer some live questions as well. So 2018, it feels like it was a very long time ago, and I was thinking about that. And it turns out it actually is, just because it is a very long time ago. But it was a pretty uneventful year. We had a royal wedding with Meghan Markle and a bunch of people eating Tide Pods, and that was kind of the highlights of 2018. But at Cisco Live in 2018, something interesting actually did happen. It was around 1 o'clock Monday afternoon. We had a full-scale wireless outage. So about 16,000 people just dropped from the wireless network all at the same time. So I mean, a wireless issue is pretty critical no matter where it happens, but imagine it happening at one of the world's largest technology conferences. So we were able to pretty quickly figure out that this is not a wireless issue. We can see that the APs are healthy, the wireless LAN controller is healthy. We know the issue is somewhere else. And I think this is a very common challenge that a lot of organizations run into. You'll have a critical outage of some kind. It's easy enough to use modern tools to figure out that, hey, the thing that we think is broken is not actually broken. But where do we go from there? That tends to become a bit of a time-consuming and complex problem to solve. The reason for this is because we have all of these different technology domains. And they all do something very specific in our environment, which means they all have pretty purpose-built tooling to actually do those things. So within a domain, we can have a lot of data and a lot of visibility, and we can easily solve problems. But we don't really have anything that can help us stitch all of that data together and make sense of it for us. So when we have a problem like this, we end up relying on our own expertise and our own time, and we chase clues across domains and tool sets and even multiple teams until we figure out what the problem is. Now, in a perfect world, we would be able to ask the question, why is my wireless down? And I would get a single meaningful response that actually helps us solve the problem. So this is one of the use cases that AI is going to start to give you access to once you start integrating your platforms with AI. And that's what this session is all about. So yeah, we're going to talk about MCP. This is the protocol that actually makes all of this possible. We're going to look at how it works, what it is, and how you can actually start using it today. Then we'll look at some real-world examples of AI communicating with platforms and how it interprets that data and can help you make changes within those environments. And then I'm going to show you how easy it is to actually take that and turn it into a full-fledged AI agent that can automate any repetitive workflow. Now, the evolution of how we actually interact with our devices is pretty fascinating. Before we had CLI, we used to use physical dip switches to actually apply changes to a device. So this was really proprietary, very time-consuming, and very limiting on what we could actually do with that. So in the early 80s, when we started using CLI, this was a very welcome change because, for one, it gave us a consistent interface that we could use across many different devices. And the syntax might have been a little different, but the way we connected was the same. And then it gave us this efficiency because now we could configure our devices with a keyboard. And that's why CLI is still commonly used today. And I'd guess that most people in here still remember the very first time that they used CLI because it's actually kind of a fun experience. I was sitting in a classroom, I had a black screen just like the one you're seeing there with the green writing, and you kind of feel like a 1980s television hacker. And I think that's exactly how you want to feel when you're configuring a network. But the downside here is that once you start adding more and more devices, it becomes time-consuming and it becomes complex. And as soon as we hear those two things, we use AI to overcome those challenges today. So managing, monitoring, automating our networks, this is a perfect place to start layering on AI. And if we look at how technology is trending, there's a very good chance that AI would be the next evolution of how we start to actually manage our devices. And we can do that in natural language. So it's not likely that CLI will go away completely, but I think a lot of the things that we do on a day-to-day basis could now be done with natural language. So when you start integrating AI with your environment, the initial or the biggest value that you're going to get is this entire layer of intelligence that you bring into the network. So think about the smartest person that you know, and now all of a sudden they have all the time in the world to come to work with you and help you with any challenge that you have or with any task that you want assistance with. That's what we get with AI. But there are some very specific things that we can also do within our network space. The first is intent translation. So think about how we actually configure devices today. We have to think about what the device is, we have to think about what we want it to do, then we think about the protocols and features that we need to enable in order to do that, then we have to think about the syntax, and then what's the most efficient way to actually apply that. And if we have multiple devices, it might be different for each one of them. With AI, I can just tell it in natural language what I want it to do, and it will figure out how to do it for me. So I can say, set port 15 to VLAN 100, and AI is going to be smart enough to know how to do that. And if I have 10 different switches from 10 different manufacturers, I can do the exact same thing. I can say set port 15 to VLAN 100 on all of my switches, and again, it'll figure out how to do that for me. And the great thing here is I don't even need to know what a VLAN is. I can just say, I have a client on port 15 that I know I need to isolate. How do I do it? And it can look into your platforms and then say, hey, these are your options. What would you like to do? And if you don't understand, you can ask for more info, and when you're ready, you can get it to actually apply those configurations. And this is a pretty basic example, but you could expand this into pretty much anything. You could use AI to help you deploy full-fledged fabrics if you wanted to. The other thing here is cross-domain reasoning. So think about the issue I talked about at Cisco Live. That issue took us 30 minutes to resolve. We had, it was an upstream switch that had full TCAM saturation. Took us 19 minutes to figure that out, and then another 11 minutes to actually reboot that switch. So with AI, if we had all of our data in AI, it's designed to process data. So there's a very good chance it would have been able to give us the insights we needed in order to resolve that issue much faster. The other thing is if we were using AI agents, we probably could have avoided that entire issue altogether and just rerouted our traffic. Now, the way we actually get our data into AI is through a protocol called MCP. So this is Model Context Protocol, and it's the actual platform or protocol that allows AI to interface or directly communicate with your platforms. Without this, think about AI as being very siloed. It has a lot of data that it was trained on, and you can pass data into it, but it does not have the ability to actually reach out on its own. So once we have these two things in place and you've integrated your platforms with AI, those silos, they're still there. You still have all that domain-specific tooling that we talked about before, but you get this additional layer of visibility that ties everything together. So you get context-rich visibility across all of your different domains. You can apply configurations across your domains. You can apply policy across your domains, and all, of course, in a very consistent way. So this would make things happen a lot faster and obviously reduce a lot of complexity as well. So again, MCP is the protocol that allows this. If you've seen Lord of the Rings, they talk about the one ring to rule them all, and this really is the one protocol to rule them all. It was released by Anthropic as an open standard in late 2024. So in less than 2 years, it's become the de facto standard for how absolutely everyone connects their platforms into AI. It's a universal connector. So think about USB-C, for example. Before we had USB-C, you had to carry around a bunch of different cables. If you were at a conference like this, you'd probably have 5 different cables with you. Now there's a good chance that you just have one cable, and you can connect pretty much any peripheral with that cable. That's exactly what MCP is when it comes to interconnecting your platforms with AI. It standardizes the way that AI can communicate with your platforms. It's vendor agnostic, so we don't actually care who owns the platform or even what that platform is. As long as you have an interface that you can manage the platform with, we can standardize it and present it to AI so that it can then interact with it. I wrote down here at the bottom that over 20,000 MCP servers on mcp.so. So when I made this slide, I'd actually checked and it was around 17,000. That was probably a month ago. And I just guessed that it would be over 20,000 by now. I checked yesterday, it's 22,000. So the rate at which people are releasing MCP servers is extremely rapid as well. Now, MCP is a client-server model. I learned that I'm a total nerd when I built this slide and the one after, and it took me like 30 minutes to talk through them, so I'll try to do it a little bit quicker. The actual MCP client lives inside the AI application that you're using, and its job is to sit between the LLM, which is the large language model, and then between the actual MCP server. The MCP server is that platform adapter. That's what's actually going to standardize the way that we communicate with the platforms. You will typically have a single MCP server per platform, but that's not always the case, and I think you'll see that in a couple of slides from here. The other thing to remember is that the MCP server does all of the heavy lifting. If we actually are making a request or doing something with the platform, that will actually happen from the MCP server. Anything that gets returned will get structured, and it'll hand it back over to the actual client. The MCP server itself can run in two different places. So it can run locally, which means it's going to actually live on the device that's hosting the actual LLM or the AI client or the AI application. And if you do that, this is kind of ideal for single device, single user, any kind of development environment, but you will also actually see most consumer or business grade applications that integrate with AI. If they're doing that on the desktop, they will spin up a sub-process, which is an MCP server, to communicate with your data and then whatever LLM they have in the background. When you are running it locally, it uses something called STDIO, which is your standard input-output. So we don't have to worry about any kind of network. There's no latency. It's very simple. But there's also no authentication. And that's probably OK for most of these use cases. We kind of just treat our devices as being secure, and the communication between the applications we can allow. If you want to scale it out and you wanted to have more agents having access to it or more users accessing the same MCP server, you would run it remotely. And when it is run remotely, everything is exactly the same. Like the MCP server, the standard, it's all the same. The only thing that's different is the transport, how we're actually transporting that data across our network. This is going to be great for like the majority of things. I actually think it's a lot easier to just run it remotely, keep it running all the time, and have access from absolutely anywhere. But one thing to keep in mind here is that it is going to be out there. It's going to be accessible to a lot of different devices or people. You're going to want to make sure you're using authentication. And authentication is part of the standard, but it's not enforced anywhere. So if you're trying to tie in a remote MCP server to some kind of an AI application, it's never going to make sure that you have authentication. So it's totally up to you to make sure that you are actually doing that. All right, so every single MCP server can expose three different things. The first is going to be a tool. And a tool call is going to be any kind of action that an AI model can take. So whether it's going to grab information from a platform or push some kind of change, that's going to happen through a tool. And to be honest, this is actually the only resource that we typically use from an MCP server today, but there are still two other options. You can share resources. A resource would be a static file. So if you wanted to share details about your environment or details around a specific process that you want the AI to follow, you could technically do that with an MCP resource. And the last option is a prompt. So we can build predefined prompts that AI will then discover, and it will use them if it thinks it needs to. So that's kind of the key here. I could make a prompt that says troubleshoot wireless, and it might have all the details that the AI needs about my environment to troubleshoot wireless, what tools it should use to actually pull information. But the thing about MCP is that it's model controlled, meaning it's entirely up to the AI model to decide when it's going to use any of these. So you can have all the best resources and prompts in the world, and AI might never actually look at them. You can influence it by saying, hey, I want you to do this with this tool from this MCP server. And it's kind of like a 10-year-old kid. Like, it will probably listen, but it does not have to, right? It's still entirely up to the LLM if it's going to actually use these or not. Now, I think this is probably one of the more important topics here. A tool call can be more than just a simple tool. So when you're dealing with an MCP server, especially if it's from a vendor, it's going to be a series of simple tools. And a simple tool is going to be a mapping of a tool to an API. So you might have 100 APIs, and you'll have 100 tools that align to those. That works really well, and in a lot of cases, like, that's going to be more than enough. But there are certain things where it's not going to be the most efficient way to do things. So we have another option here, and that's to use what's called a workflow tool. So in the background now, we build an entire script that's going to do a lot of different things, But from an AI perspective, it's just going to call a single tool. So the example I'm going to use here is to deploy a branch network. If I wanted to deploy a branch, I could get AI to do it with simple tools, but it might be a little bit different every time, right? Because it's going to think through the process and it's going to choose the tools it's going to use, and it could easily miss something. Whereas if I build a workflow tool, I can guarantee that every time it's going to go through this exact process. It's going to create the network, configure the VLANs, set up the SSIDs, the firewall rules, and everything else that I need to do in order to deploy a branch site. The other thing you can do with this is you could start to track it, right? So AI deploys the site, it then updates some kind of document, so you have reference to all the sites you've deployed, any changes you've made. So I actually there's a QR code, you'll see in a number of my different slides here. I did a full kind of blog post with step-by-step instructions on how I built kind of a template engine that separates you from the actual vendors, because I'm sure you've probably all run into issues with templating where you want to do something and it's not supported. So you can definitely like expand upon this in a million different ways. The other thing you can do here is present data. So think about that example of troubleshooting wireless. I could have a tool that in the background gathers data from 5 or 6 different platforms, bundles it all up, and sends it up to the LLM so that it can process the data. There's a good chance the LLM would have got that data on its own anyway, but it would have taken a lot longer and it would have wasted a lot more resources to actually do it. So what does an actual MCP call look like? It's going to start with your initial request, and this is coming from a user. We're going to ask, why is my wireless down? But this could come from an agent or any other automated process as well. The first thing that's going to happen is that the LLM is actually going to process your request and figure out what are you actually trying to do. So when it says, why is my wireless down? It's going to first of all figure out, do I already have that information? And if I don't, I'm going to start looking for a tool so that I can start to find it. And it'll upload all of your tools. It'll start to figure out which is the best tool. When it chooses the right tool, it's now going to pass that tool or that request over to the MCP server. MCP server will validate the request and then send it off to the platform. So it's actually going to go out and make those requests on your behalf. It'll then receive the response. It will structure it, send it back to the client. The client and the AI LLM are actually, they're pretty much holding hands, so they just pass it over to each other. The LLM is then going to process that data, and that's how you end up getting your response. So there is a lot of different steps that happen here, but it does happen very efficiently because the standard is so well defined. The other thing that will actually happen more often than not is that this whole process will be repeated several times in order to actually complete your request. And in many times you'll see recursive lookup. So it might see, oh, I need to use this tool, which is list networks, but in order to get there, I need to figure out what the org ID is or what the network ID is. So it'll then find a tool to find that so that it can actually input it in the actual final tool call that it's going to make. All right, so every single MCP server is made up of 3 specific things. It's going to have a name. That name needs to be descriptive and boring. So if you're doing something like, if you're making a Meraki MCP server, you should just name it Meraki, because the LLM will actually use that information when it's deciding which tool set it's actually going to start to look at. The next thing is it's going to have to connect to a platform. So this could be, you could connect to a platform in a number of different ways. Like we're going to use an API here, but you could use SSH, you could use HTTP. There's lots of different options. The most common is going to be APIs now. And you will probably start to actually see vendors very heavily focused on things like APIs, just so that we have better integration with AI. And then the last thing is going to be that menu of tools. I say tools here, like it's majority of the time, actually we've only ever really seen people use tools to date, but this could also include, of course, the prompts or the resources as well. And this is what it actually looks like in code. So a Python script that exposes a single tool is less than 10 lines of code. We bring in the fast MCP framework, which is the library we're going to use. This is by far the most commonly used framework for actually building MCP servers because it is very straightforward. And then there's those 3 things I talked about, right? We give it a name, in this case Meraki. We give it a connection to a platform, which is the Meraki dashboard via an API. And then we define our tools. There's one more step, which is to actually run it. And then when we actually run the MCP server, it's going to be a little bit different whether you're running it locally or remotely. If it's remotely, you're going to manage that entire life cycle of that MCP server yourself. You could deploy it in a container or as a service on a Linux box, or you could just manually run it when you want to actually reach it. If it's running locally, the actual AI client will have some kind of a config file, and it will load this up as a sub-process every single time. But a tool call is also made up of 3 things, so I want to call that out here. You'll see that we have the definition, which is get network health. That's going to be the name of the tool. The get health status for Meraki network, that's my description. And then we always have an input schema if we need to have input. So the input schema here is a network ID in the form of a string. For every single tool, those 3 things are going to get shared with the LLM. All right, so we're going to look at a demo here. I'm going to basically connect some MCP servers to Claude as our AI client, and I just want to show you how it actually gathers data and then processes that data. So from this portion of the demo, I want you to see how we actually connect to the client, how the client decides to use a tool, how it then interprets the data, and how it can also make changes within that data. And I wanted to show you this really quick. I mentioned that if you are running it locally, there's going to be a config file. In my opinion, this is actually probably the most intimidating part about using an MCP server or making your own MCP server. But it is very straightforward. There's 3 things. There's a command to actually what we're actually going to run the script with, which is Python in this case, as well as the environment where it's going to run in. There's a script name and location, so where's my actual server living, and then any kind of credentials that we're going to have to actually connect it to that platform. The good thing here is that you don't actually have to do this yourself. You can typically ask AI to just do it for you. It will have access to this file so that you never even need to open it up. Now, every time you restart your client, it will automatically boot up this MCP server. If you're doing it remotely, it's a little bit more simple. You just have to you give it a name, of course, that's your local name. Then you have the remote server URL, as well as your authentication credentials. So super straightforward to actually connect to any kind of remote MCP server. Let me swap over here for a second. Let's go ahead and dismiss that. Okay, so this is what the Claude interface looks like. And I wanted to show you here, under Customize, you have your connectors. And I have a number of different MCP servers that I have added in here as connectors. And if you wanted to add more, you just hit plus, add custom connector. But there's also hundreds of pre-made connectors that you can tie in here as well. So if you wanted to tie into any kind of platform, there might already be a connector for that. Within these, you can see my tools. So here's my Meraki MCP server. There's 151 tools. These are all simple tools, so that one-to-one mapping of tool to API. And then we also have permissions. So right now I have set to always allow. By default, it will be needs approval. So if you add an MCP server in here, it's never going to be able to use those tools without your consent first. All right, so I have way too many cool things to show here, so I have to go pretty quick through this. To start off, I asked it to list my Meraki MS switches in the organization CraigWickham. And the first thing it's going to do in order to find that data is it's going to realize, for one, that it doesn't have that data yet, so it needs to start loading tools in order to find it. So that's what it did first. And it kind of tells you along the way exactly what it's doing, so you're not left in the dark. But here it is. It did this little query here, loading tools, and it did a query for any tool that's going to look at list organizations Meraki. Not all clients are going to do that. So some AI applications will just load all of the tools, and then it's going to go through them, which is a massive waste of resources and context. But more modern platforms will have the ability to kind of query and figure out which tools are going to make sense without necessarily having to load them all into the actual context window. From this, it figured out that it was going to use the list organizations tool. And the reason it was doing that was because it was trying to find what tool would give it the org ID for the organization CraigWickham. And here you can see the actual response. The org ID is 770980. And above it is where you would actually see any kind of input that it needed to send with that tool. And in this case, there was none. So it can run this tool without sending anything and just get a list of organizations associated with my API key. Further on down here, it tells us, yeah, I found that org ID. Now let me find the inventory for the switches. So it does the exact same process. It loads the tools again. It does another query to find a tool that's going to help it list organization, inventory, and devices. And from that, it chose to use a tool called Get Inventory, which you can actually see here. It plugged in my org ID that we saw earlier. It also added a filter for MS. And this is pretty cool because it returned 3 different devices, and there was a bunch of other devices in there. It returned anything that would have had MS somewhere in its response. So what's cool is we got 3. There's only 2 MS switches. One of them was returned as an MX, which is a firewall. And the reason for that is because in the serial number, it has MSM. So the AI was pretty much instantly realized, hey, this is a problem. I'm going to now filter that out, and I will just give you the list of 2 MS switches, as well as any other information that it got from those specific tool calls. For instance, the MS350 that it listed here is end of life, but we do have support until 2030, so it told us that as well. Now, pretty much every conversation will look the same, but how it processes the data or interprets it is going to be a little bit different. So I'll show you a couple of other things here. So in this example, I asked it to, I said, I'm having some trouble with layer 2 loops on this specific network. Can you tell me if I have any switch ports that have spanning tree disabled? And it did this across both Meraki as well as some independent Catalyst switches. And you can see here, it actually went through quite a long process to get all of the data it needed. And then it told me, yep, you have these 5 ports that have spanning tree disabled. One of them is extremely concerning, which is the trunk port, because we know it's connecting to other switches. So it goes on to give us a bit of a description of why this is troublesome. It gives us a breakdown of what it found and where our other switches are all looking okay. And then it told us that the likely culprit is the port 14, which is the trunk. However, it kind of suggests that we re-enable spanning tree across all those ports. And also, it suggests that we enable BPDU guard on the access port. So just some additional info on how we can harden and prevent this issue in the future. I did ask it then to go ahead and re-enable it on all my ports, and it went through one by one, and it configured the switch port, used the tool configure switch port to actually re-enable spanning tree. Now, if you've used Meraki in the past, it would have actually taken quite a long time for a human to click through each port and figure out which ones actually had spanning tree disabled, whereas here it's just a couple of minutes with a conversation and we're good to go. All right, so I'll show you just a couple of more simple examples, and then we'll look at just one more where we analyze some data. I asked it to generate an end-of-life report. So we probably all have platforms where we are trying to figure out refresh cycles and if we have devices that are end of life. In this example, I am just doing it with Meraki, but you could do this again across multiple platforms all at the same time. What's cool here is that it gathered all the data from the network, so it gathered the list of my devices. It also searched the web to reference any kind of public end-of-life announcements. And then, if I scroll down here, it built us this end-of-life report at the bottom that lists all the data of my different devices, where they're located, their current status, and so on. So I now have a really great report that I can use to build my refresh cycle. Another example is to do a network topology. I just asked it to build a topology for my HQ Meraki network, and here it is, right? So I have a complete up-to-date list of how my network is connected, all the different sensors that I have, even if there's a VPN connection or pretty much anything that the LLM could actually see from the tool calls that it did in order to gather this information. All right, I asked it to do a Meraki security audit, and I'm being so general with all of my requests. You could be a lot more specific in kind of tuning these requests so that you get something more specific to your actual need. But I wanted to show you here, it gives you a really nice kind of report style of what we're actually looking at. So what are the issues that I should be concerned about, my overall health score, my critical findings, and I want to call out one here. So it found out that all 3 of my SSIDs have a pre-shared key. Meraki is sharing that pre-shared key with plain text. So when I call an API that's going to return that information, it's just sending it in plain text. But the other thing is, it went on to say that your pre-shared keys appear to be phone numbers, which are easily guessable and most likely tied to you, so you should probably rotate those immediately. And I want to call that out because I don't think there's another security tool in the world that would pick that up just in a pretty quick security audit. And then I just want to show you here as well, like it formats it in a way that you can like really just click through. Like it's built a front end for us to actually just view this security report. All right, let's look at one more example here. So you can tie, the great thing with MCP is that you really can connect any platform to the LLM. So I have a NetFlow server, so we can get raw NetFlow data and have your actual LLM analyze that data. There's also like protocols or platforms like Zeek, which is an open source tool that lets you gather data from the actual client. You can tie that into MCP, and essentially you're communicating at the packet level through an LLM. So I asked it to analyze a client, 192.168.1.34, and it did a couple of things. I want to show you, it used a troubleshoot client tool first, and this is a workflow tool that gathers a bunch of data from Meraki, as well as a bunch of raw flows from the actual NetFlow server. And this is its initial findings. It tells us this is the client's name, IP, the MAC address. It is a critical, we have some concerns with this client right now. This is where it's connected to. It's connected on VLAN 1. It was first seen on March 16th, and it was last seen on May 11th. This is a bit of an old report here. And here's some details around it, right? So the outbound actual traffic, the amount of flows, the unique destinations, unique ports. But what we're concerned about here is port scanning, some unknown C2 beaconing, and multi-port probing, as well as a number of other things that it's calling out. So I'm going to scroll down. It gives us a lot of information, and it tells us that this device it seems like it is a compromised host, and here's the summary of why we think that. And if I keep scrolling down, it says, I strongly recommend that you actually contain this device immediately. So I asked it instead, let's take a look and see if there's any east-west traffic to make sure that it hasn't infected anything else. So it pulled some more data directly from the NetFlow server this time, and it was able to validate that there was no east-west traffic, gives us some more details around some of the other traffic because now it has some more data. And then it says, I still recommend that you should isolate this client. So I said, yep, let's go ahead and isolate the client. And it gives me a summary of what it's going to do before it actually makes the changes. It will often do that. It will not always do that. And if I scroll down here, it actually goes and uses the tools to disable the port. And the key thing here is it also renamed the port to isolated. So we didn't tell it to do any of this. It was just smart enough to know that if it doesn't update that name, there's a very good chance that at some point, someone's going to turn that port on by accident, and we're going to have another problem on our hands. So super cool. And you can actually do this for, like, I asked it to kind of analyze my entire network from a traffic perspective. Again, it builds like a very beautiful table of data so we can kind of see exactly what's going on. It even decided it would put in a z-score here. So this is your anomaly score. Are we seeing a lot of anomalies or not? Right now, it's pretty normal. Host deviations, new hosts, port anomalies, country deviations, and then it goes on to give you a breakdown of all your different priorities. So, I mean, the first time I saw this, I was completely mind-blown that it would not only gather all this data, but also format it in such a readable way. So let's jump back into here. I just want to show you here, this is what it actually looks like in the Meraki dashboard. So the port is now disabled. And you can see at the top there, it is now isolated. So no one is going to make the mistake to turn it back on. So for all of the MCP servers I made, and some of the other use cases like automation and things like that, which we didn't really have time to like demo from an LLM perspective, I do have a complete kind of lab guide blog post about all of these, and all accessible through my GitHub as well. So as useful as that is, and I think there are pretty much endless use cases for being able to just naturally communicate with your network all the way down to the packet level, another big value add from integrating your platforms with AI is the ability to start building agents. So how do we actually go from an LLM to an agent? And a lot of times people will ask, or people will be intimidated when they hear agent because they assume it's going to be complex. It's very far from complex. It's actually just a prompt. So anytime we're dealing with AI, it is usually just a prompt, and I'm sure everyone here does prompting every single day. So let me just move on here. The other question actually that people ask a lot is, what's the difference between an AI agent and some kind of traditional automation? Traditional automation is always scripted, and we script it, so it's very structured. An AI agent is goal-driven, so we tell it a goal, and it figures out how it's actually going to accomplish that goal. So to go from an LLM to an agent, there's three kind of key components. The first thing is that every agent is going to have a trigger. That trigger could be a manual trigger. It could be periodic, meaning it's scheduled, right? Every 5 minutes it's going to do something, or every 100 years, or whatever period made sense to you. And then you can do it with a webhook. The webhook is very convenient for us as network people because pretty much every platform that we deal with is going to have webhooks for their alerts. So we could grab a Meraki alert and have that trigger our actual AI agent. The next part of this is the actual prompt. So I might say something like, you are a Meraki IT troubleshooting assistant. I want you to analyze the details of this alert and tell me why you think it happened, how I can actually confirm that, and how I can resolve the issue. And then every single agent is going to have an output. So what do we actually want to do with that information? Or what task do I want it to actually do once it's figured out something, right? I could have it sent to a WebEx Teams room, to a Microsoft room. It could call you and describe it to you. You could turn a light on and off. There's an endless possibility of what you can actually do with the output itself. So these three components make up a basic agent. But if you want to do anything more advanced, there's two other components that you're probably going to need to add. The first is memory. When we communicate with an LLM like on our desktop, like Claude or ChatGPT, we have this massive context window, and it stores all of the information that I need in order to have that conversation ongoing, right? It's not starting from scratch every time I send it a new message. When we use an agent, we're going to actually tie it in through an API, and in order to do that, every single API request to an LLM is going to be a new LLM request. So it doesn't have that context anymore. So we need a way that we can actually store that conversation over time, and we do that with memory. And most applications will have a simple memory built in, but you could tie this into a text file, into a database, whatever you wanted. There's a lot of different options here. And the last thing, of course, is tools. If you want your agent to actually do anything useful within your environment, you are going to need to have tools in order to give it access to that environment. And we are going to expose those tools through MCP. So I'm just going to show you an agent demo, so how we actually can build an agent very easily. We're going to look at 3 levels of a guided remediation agent. And the first level is exactly what I described before, right? It's going to receive the webhook. That's going to trigger the actual agent call. And it's going to figure out why it thinks we're seeing this, how we can verify, and then how can we actually resolve that issue. And then it'll send it off to a WebEx Teams room. The next level is going to have MCP tools, so it can actually go into the environment and verify what the issue is, and then send us a much more concise response. And then the third agent, we're actually going to just allow it to fix the issue for us. We're going to add something else, though. We're going to add a human in the loop, which means I get to say, verify that, yep, I do in fact want you to go in and make that change. This is my topology. It's actually really straightforward. We have the Meraki dashboard, which is managing 2 switches. And these switches are interconnected in a bad way. One is access port, one is a trunk, and that's going to give us a port VLAN mismatch. So this is a pretty easy issue to fix, but it is one that could also give us a lot of grief in our networks. The other thing you'll see here is that we're using something called N8N. This is the actual flow-based automation tool that we're going to use to build the agent. I like this tool because it's pretty easy to use, but it is also very powerful. But there are literally hundreds of other options out there. And you could even just use a Python script, which is probably becoming the more popular way, because then you can just ask something like Claude to build the agent for you. All right, so let me jump back in here. And hopefully this all works, because everyone said I was absolutely crazy for doing a live demo. So this is my Meraki switch here. You can see that it is in an alerting state. It has a port VLAN mismatch, and port 21 is connected to my MS-130, and it is set up as an access port. I've already received the webhook, so I have a separate flow that grabbed that webhook so that we can use it for all 3 of these different demos. And I just wanted to show you, this is the payload. It's just a big, nonsensical, formatted JSON response, right? So a lot of different data about what the alert is telling us. And then here is my first agent. So there's 3 parts of it, just like we saw before. There's the trigger. This would normally be a single box, which would be that webhook. There's the actual agent, which is our prompt, and then there's the output. So treat the green part as a single block. I want to show you here, if we wanted to build this agent again, it's just a drag and drop box. So there's nothing fancy about it. You just drag it onto the dashboard here. And then when I click into it, I can give it a prompt. This prompt might look big, but the only thing we care about is the top part. I say you are an IT troubleshooting assistant, analyze the following Cisco Meraki alert, and produce a concise operator-ready response. Everything else is just formatting how I want the agent to actually send the response. And then, as far as the actual output, it's just an HTTP request to a WebEx Teams room. But again, this could be absolutely anything. And I'm going to go ahead here and execute the workflow. And you're going to see, like, it grabbed the webhook. The agent is now looking at the prompt. It sent it off to ChatGPT, and we are waiting for the response. And once we get that response, it's now going to send us a WebEx Teams message. And let me just show you what that looks like. So here it is. So it's given us an issue overview. So we have a VLAN mismatch. It's given us some potential issues in priority order. And the first one is actually correct. One port is set as a trunk. The other is set as an access port. Here's some details on how you can confirm as well as resolve that issue. So even this most basic level of agent could be pretty useful because we could just send this over to ServiceNow, open a ticket, and now our most junior employee could go in and solve this issue for us. I'm also completely general on how I've built the prompt, right? Like, you could also have much more specific prompts for specific types of issues. You could have an agent that actually triages alerts, so it sees, oh, this is a wireless alert, let me send it to our wireless specialist agent to actually resolve the issue. Let me show you the second version here. So everything is exactly the same, except for you'll note that we have added this Meraki MCP tools. And I'm just gonna scroll in here. You can see, like, as part of the agent, we get to select our chat model. We're using ChatGPT for this agent, but we could use absolutely anything. Not all LLMs are built equal, so pick one that will actually be able to do the task. And then we just clicked on tool and I added the URL for my Meraki MCP server. And then I did tweak the prompt slightly. So now we're saying that there's another section here that says, use the Meraki MCP server to actively confirm the issue before providing remediated guidance. So still, again, it's just 3 sentences for the actual prompt. And I'm going to go ahead and run this for you. And you will see that we have a much more concise prompt here. So you also see that it actually jumps between the OpenAI chat, which it had 2 different prompts that it sent, and it used one tool to actually get this information as well. And here it is now. So the last one was quite long, a lot of different detail about potential issues. Now this one is, hey, this is the issue. We have a port VLAN mismatch. One is a trunk, one's an access. And it goes on to tell us that we need to change the port to type trunk. So it's also following best practices, and it's doing that on its own, right? It could have changed the other port to an access or an access port very easily as well. And I will just show you this last one really quick here. This one looks a little bit more complicated because we actually have 2 different agents. So you'll see that we have an if statement at the beginning, again, another drag and drop box, and it's checking, hey, is this a new alert, or is this a response from someone that wants us to actually resolve an old alert? If it's a new alert, what we're gonna do is we're gonna send it over to that guided remediation agent, which is identical to the last example. The only difference here is that we've added a simple memory node so that it can actually store its conversation. And now when we actually go to resolve the issue, it doesn't have to do all that work again. It can just pull that information directly from the simple memory. The other part of this here is the resolution agent. So this part of it is just formatting or grabbing the data from the actual webhook that is getting sent back when the user clicks and says, yep, I want you to resolve that. But here's our prompt. And you can also see I'm using Anthropic here. So we're using 2 different LLMs. We could use the same one. It's totally up to you, however you want to do that. This prompt says you are a Meraki remediation agent with access to MCP tools. You have access to all Meraki devices via the Meraki MCP server. And then we're passing it some data. This is the alert data that was sent back from the last WebEx call. And then this is the actual previous diagnosis from the memory. And then again, everything else is just some instructions on kind of how we want it to format or what we want it to do here. So it's really simple to build a prompt. So what I'm going to do is I'm going to execute this workflow. There's another box down here that you can see. This is just formatting it so that it's going to add that human in the loop. And then we also added a delete from queue. So it's going to actually delete that old webhook alert that we had so that we make room for the new one that's going to get sent in. So it has completed its flow now. I'm going to go back to show you what this looks like. We generated a card because we formatted it a little bit differently. And it's all the same info that we saw in the same last response. It wants us to actually change that to a trunk. And then it asks us at the bottom, do you want us to resolve this? So I'm going to click resolve the issue. It's already sent that webhook off. So when I go back in here and I run this again, we're actually going to see that it's going to get routed over to our resolution agent, who's now going to actually go into our platform and make that change for us. So it's already done that. I'll just show you the response here. It's telling us that it's gone in, it's changed it from access to trunk with allow all VLANs and native VLAN 1. And let me just go back to this Meraki dashboard. We're going to refresh. You can see this is an access port. I'll just refresh this here, and you can actually see that it is now a trunk port as well. So it usually will just take a couple of minutes. You'll probably hear a ding ding, and that's the alerts getting cleared off in a few minutes. So pretty powerful. Super simple. Anytime you're dealing with an agent, it is, again, just a prompt. So I think anyone can make an agent that can do pretty much anything you actually want it to do. So think about different types of agents that you could use in your environment. And if you already have built something like this or you have some ideas, put it in the Teams room, because I'm guessing other people here would probably want to hear what your ideas are and maybe get some motivation from you as well. Just like before, there are some guides on how you can do all of this yourself, including all the actual exports of my flows as well. So easy way to kind of get started with this. I have saved what I believe to be the most important part of this presentation till the very end, which is making sure that it doesn't actually do something crazy to your environment. So there's a TV show called Silicon Valley, and it is probably one of the most hilarious shows ever made, especially if you've been to a big tech conference like Cisco Live. They make fun of big tech companies in all the right ways. In one of the scenes, though, there's a guy named Guilfoyle, and he has his own AI called Son of Anton. And the CEO comes storming over because he can't figure out why everything's broken, and it's a really important day. And Guilfoyle realizes it's possible that Son of Anton decided that the most efficient way to get rid of all the bugs was to get rid of all the software, which is technically and statistically correct, but artificial neural nets are sort of a black box, so we will never know for sure. And as hilarious as this is in a TV show, this actually happened multiple times this year and to some of the largest cloud vendors in the world. So it's not just small organizations that are having issues with this. So we need to take proper precautions to make sure that this kind of thing does not happen. Later on in this scene, they have about 5,000 hamburger patties show up at the door, and he says, oh yeah, I tasked Son of Anton with finding us cheap hamburgers for lunch. So you can see how AI would interpret that, yeah, I'm doing a great job, like I've got all these hamburgers for you, but it really doesn't help solve our problem. So the first thing that we need to do is to make sure that our prompts are very, very thoroughly thought out and that we don't leave any kind of room for guessing, right? Like if the AI has any room to guess or assume something, it's going to guess or assume something, and you're going to have a problem. There are some other things to talk about. Guardrails. So there's a lot of things that we can just do, simple things that are going to help us be more successful with this. The first is to scope your tool set. So you can have a million different tools, but you really just want to give your AI the tools that it needs to do the job. So this is very, very important if you're building agents. Give it a custom MCP server that is just the right tools for it, right? Like kind of like 10 to 15 tools anymore, and it's just not going to be very efficient, or it might use the wrong tools and then get not as much data as it should have gotten, or maybe not do the job that you actually want it to do. The other thing is you want to make sure your tools are named and have the proper description to them. So simple names and a very descriptive description so that it knows exactly what the tool is going to do. I mentioned this earlier, the human in the loop is a big component of this, and you'll see most big vendors are now doing this because it's the best way to prevent it from doing something actually crazy. Validate your inputs, right? This goes back to AI hallucinating. I think we've probably all seen AI hallucinate. What that typically means is it starts making things up. And it will do that on purpose. You will ask it to do something, and maybe it needs to gather 10 pieces of information to do that. It'll gather 8 of them and be like, yeah, I've done enough. I'm just going to put in some placeholders here or just assume some other data that you need, and that kind of ruins everything. So validate the inputs, and this ties back to human in the loop. And then the other thing is just kind of do that crawl, walk, run, right? So you want to start read-only and build your way up to actually giving any kind of agent or AI the ability to make changes in your environment. One other thing that I didn't mention before is rate limiting. If you are going to start playing around with this at all, you might run into rate limiting issues, especially with APIs. So just keep that in mind. Like, there's lots of ways around it. We can break our agent up into multiple smaller agents with delays between them. We can tweak our prompts in order to make sure that it's not doing anything extra and it's doing precisely the task that we're asking it to do. But yeah, just be aware of rate limiting. You can also often just bump up a rate limiting tier directly through the vendor. And then lastly here, AI governance. I'm not sure if you guys know what this is. This is all about creating a policy that is going to make it safe for you to use autonomous agents in your environment. And the majority of companies out there have not started to consider this, but we are seeing more and more agents. It's a very slippery slope. People will start out with 1 or 2, and before you know it, they have hundreds of agents in their network, and you have to worry about performance for those agents and security for those agents because they all have elevated permissions into your environment. So I don't have time to go through this, but there is some key things that you need to just consider and to actually get this conversation started. And again, I do have a full blog post on this with a lot more detail. So something that you should definitely start thinking about within the next couple of months here. Now, at the beginning of the presentation, we talked about, wouldn't it be great if we could just say, why is my wireless down? So I actually did do exactly that. I built an environment that has Catalyst Center, wireless LAN controller living on a virtual machine. It's a VMware environment. We have firewalls involved, and I built some workflow tools so that we can gather all of that data at the same time. And this was the actual output here. So I asked, why is my wireless down? And it is gathering a heap of data here that it's going to process very quickly. And very, very quickly, it also realizes, hey, this is likely not a wireless issue. It goes on to figure out that this is most likely a DNS issue. So it grabs another tool to do a DNS health check, which it figures out that, hey, none of our external queries are actually making it out to the real world. So we know it's a DNS issue. It also gives us some other data as to why that is the case. And then it figures out that the root cause was a firewall rule that was applied last night at 11:48. And by the way, here's the fix, right? We can either make some changes to that existing firewall rule or add rules to the policy, or we can just roll back to a previous rule, and we could just get AI to do that for us. So something that would have taken us as humans like 20 or 30 minutes to actually figure out, if we're lucky, we can do just in a couple of minutes, as long as we can get that data into AI. So we finally made it to the end. This was probably the fastest hour of my life, but hopefully there was some value here for you. My goal here was just to introduce you to MCP and kind of show you how easy it is to start integrating your platforms. And then I think the value will kind of speak for itself. You're going to start to just see value with pretty much everything you do there. And whether you start testing this out in a lab or a production environment or even at home, now is probably the best time to do this, because we really are just starting to scrape the surface with this technology. And I know, like, for me, when I started doing this, I actually was totally mind-blown by the responses. Like, the AI has come so far in such a short amount of time. It's just very impressive what you can actually do with it. So thank you guys so much. We do have a couple of minutes, so are there any questions that I could help answer? Sure.
You used N8N.
Yeah.
So where does it sit? Is it the agent?
Where does the N8N live?
Yeah.
So just before everyone leaves, I just want to mention as well, you will have the option to do a survey, and that does mean a lot to us. So if you enjoyed the session, please take a few minutes just to complete that survey as well.